Hey, just a really quick reminder before you start today's video. I want to be sure you remember that you don't have to watch every piece of this step by step while you're checking your work. If you want to, you can go through the video, check the answers. On the ones you're getting right, as much as you love the sound of my voice, there is no reason to listen to me explain something you already understand. Now, if you see something in the work I did that looks a little different, and you're wondering about that, then sure, watch that little piece. But don't feel like you have to watch every single minute of this 25-something minute video. Instead, watch the pieces for the problems you didn't understand and really focus in on those. Don't just watch to watch. Watch to learn. There's some other practice to be done, and I'd like you to have some time in class to get that started. All right? So with that said, let's go ahead and you're going to get started listening or looking at the answer to number 1. Okay, so as we go over these homework problems, be sure you have your red pen out and you are ready to work. So let's get started. So our very first problem, 65% of 186. This is a problem where you probably find it easiest to take the 65% and change it into a decimal, 65 hundredths. Remember, percent is out of 100, so if you have 65%, that's the same as 65 out of 100, but instead of writing it in the fraction form, we're going to write it as 65 100ths. So that's what that equals, 65 hundredths. There's the hundredths place right there. Once you have that set up, you're going to take your calculator, you're going to use the tools, and we're going to multiply the 65 hundredths times the 186. So 65 hundredths times the 186 is going to give us 120 and 9/10. All right, let's show our calculator away and let's look at the next one. 23% of 640. Again, probably the easiest way is to take that 23%, think of it as 23 100ths, and then write it as the decimal 23 100ths. Then we'll take the 23 100ths and we'll multiply them by the 640. Would you write a note right here? Let me get my red pen out. Write a note that this is the whole. When you see that 640, that's the whole. And what we're finding is the part. For each of these, we're finding the part, the percent of something, the portion of. So we're going to get our calculator out, and we're going to put in 23 hundredths. We're going to multiply it by the whole, 640, and we're going to get our answer of 147 and 2/10. All right, let's get our calculator out of the way and look at problem number 5. 175% of 10. Now, before we go any further on this, before we really start it, let's make sure we understand 175% is greater than 100%, which means since 10 is our whole, this answer, whatever this answer is going to be bigger than 10, because we don't have just the 10 or a part of the 10, we have the 10 and more. So let's take this problem and let's think of that 175 percent, and let's break it down. That's 100%, and it's another 75%. Now 100% of 10 is 10. 75% of 10, 75% of 10 is equal to 3/4 of 10. 75% being the same thing as 3/4. Now, you might plug this right into a calculator, and that would be fine, but I want you to think about what's happening here. So the 75%, the 3/4 of 10, what we're saying is divide 10 into 4 pieces. So think of having $10, and you had to split it between 4 different people. Each of those people would get $2.50. So if you had, let's use the space for 8 down here since we're not using it for anything else. So if you had 3/4 of 10, we would think that 1/4 of 10 is 250. And then if we multiply that by 3, we get 750. So you had to give 4 different friends, you had to split up that $10, and then you talked to 3 of them. 3 of them got together and decided they were going to take their money together and buy something. They've got the $7.50. So then to get our 3/4, to get our 175, we just put these two things back together. Our 10, which was 100%, and our 750, which was 75%, and we get 1750. So we get 17.5 is the 175%. And if I went to my calculator, this would be one more good thing to do. So let's also use space number 4 for this. We're going to go over here and use a little bit of space. If I want to do it with my calculator, I want to remember that 175% is 1.75. This 1 is the 100%, and this 0.75 is the 75%. And all together, 100% and 75% would give us 1.75. And if I did that with my calculator, let's hope I get the same answer, because if not, I did something wrong. 1.75 times 10 is 17.5. So you might just say, you might be saying right now, heck, I'm not doing all of this. I'm just plugging this into a calculator. And that's fine. But you should understand why it works. All right, we have a couple more on this on this page of problems. Let me get that out of the way. And remember, at any point here, you can pause the calculator. You can pause the video and take some notes and then start it back up. You're in total control of the speed at which this goes. So going to number 7, we're going to go back to the traditional 32% is 0.32. And we're going to multiply 0.32 times 4, 0.32 times 4 for 1.28. So you can see 32% of it is just a little more than having 1/4 of it. 1/4 of 4 would be 1. 32% is 1.28. And finally, 23.5% of 128. This is a great problem because it starts to show us what happens when we've got this decimal in our percents. So a common mistake students would make here would be to either leave the 5 off, or they would suddenly change this 2 to a whole number. We want to be sure we avoid that. 23.5%. We want to think about what we've done on all the rest of these. So there was 32% was 0.32. If I scroll up a bit, 23% was 0.23, 0.23. So we know that this 23, if we look at that one and we look at this one, we know it's going to start out 0.23, and in this case it's going to be 0.235. If you were thinking of that as a fraction, it would be 235 thousandths. Not hundredths, like this 65% was hundredths, because we had 2 places, but since we have 3 places after the decimal, it would be thousandths. So we're going to take our 0.235 and we're going to multiply it by 128. Now 23% is a little less than a fourth, so that should give us an idea of what's a reasonable answer. Multiply it by 128, and we're going to get 30.08. So 23.5% of 128 is 30.08. So replay whatever of this you need to and get your notes down and then start the video up again and we'll move on to the next page. I'll see you there. All right, so problem 22. We are asked this question. Suppose that you add 10% of a number to a number and then you subtract 10% of the new total. Is the result going to be greater than, less than, or equal to the original? Explain your reasoning. So I think if you asked 50 people this question, most of them would say it's going to be equal to, of course, because you added 10, you took 10 away. But you're going to find that's not really true. And let's check out an example to show why it's not true. So we're going to start with the original number of 100. And we're going to add 10% to it. So there's our 100. How much is 10% of 100? Well, 10% of 100 equals 10. So we're going to add 10 to our original, and we're going to get 110. Now they want us to take 10% away. Let's switch to my takeaway color, red. So then we have to ask ourselves, what's 10% of that new number? What's 10% of 110? And that answer is 11. So we have to take away 11. And when you take 11 away, you end up with 99. You end up with an amount less than. So our sentence is going to be, you will end up with less than the original, so less than the original number, sad face, because you lost money there. You'll end up with less than the original because as soon as you get that new bigger amount, 10% of that bigger amount is more than the 10% of the original amount was. And just in case you think, well, that maybe that works because it's 100, let's take 20. So there's your original number, 20. So 10%, let me get my 20 over the side here a little bit so I got more room to work. So take that original number, and 10% of 20 is 2, so we're going to add 2. Then we've got to do 10% of 22. And that equals 2.2, so we're taking away 2.2. And that's going to give me an 8, and a 9, and a 1, and now I've only got 19.8. All right, on to number 24. If you found the percent of a number, and the product is greater than the number, what do you know about the percent? Well, what did we say earlier? If the product is greater than the original, what we know is the percent was greater than 1 whole. So the percent is greater than 100%. And we saw that problem back. Let me take you back for a minute. Go back. we saw that problem right here on number 5, where we had 175% and we ended up with a bigger amount at the end. Notice all the rest of these, it's smaller. 23.5% of 128, 30.08, smaller than the 128. 32% of 4, 1.28, smaller than the whole, which was the 4. But when we're here, 175% of 10, 17.5, bigger, greater than the original whole. So that's what we know. Anytime you end up with a product greater than the original, product, the percent was greater than 100. And let's write this down. That is what you get when the part, that's what you know, when the part is greater than the whole. We're going to try to use a lot of this math language here. All right, finish your notes on this one, and then meet me on page, 110 to do a couple more problems. All right, if this were a horse race, we have rounded the clubhouse turn and we're in the home stretch. That means we're seeing the finish line of going over these problems. So problem 37. Table shows the result of 200 movie rental customers. How many prefer horror movies? So this is going to be pretty straightforward for us. We're going to identify the horror movies. We know this is in percents. We know that 46% is equal to 0.46. So we're going to take our 200 and we're going to multiply it by 0.46. And that's going to give us 200 times 0.46, 92 customers. Now, since this was the number 200, we could also think of it this way. We know that if you had 0.46 times 100, you would have 46. Since it's times 200, we would take that 46, multiply it by 2, and there's our 92 also. But there's no reason not to use our calculator. There's a good reason to understand why it works. All right, tuck my calculator away and let's take a look. The graph shows the Ramirez family budget. Your budget's based on a monthly income of $4,000. Would you write down that that $4,000 represents the whole for each of these problems? That is the whole. I'm going to go back up for just a minute, and I'd like you to identify this 200 movies right here. That's the whole. Whenever you're doing percentage problems, it's important to know what the whole is. All right. So to the Ramirez family. Question number 1. They budgeted $1,500 for rent. So we're going to find rent. We're going to go down 50%. So what is 50% of 4,000? And this is a place where it's probably easiest to think of it as a half. So a half of 4,000 is 2,000. It is not 1,500. That one's false. The family budgeted $800 for food. So I've got to get some workspace here. I'm going to put this away for a minute. Remember, you can come back and see it again. You can probably see it with your young eyes right there. And we're going to do the family budget for food. And just to identify my work, we did the work for A. I did the work for A in red. I'm going to do this next work in purple. So my B work, when I stick it over on the side there, it's going to be in purple. So 800 for food. So we're going to find food right there, 20%. So we're doing 20%, which is equal to 0.2, and we're multiplying that by the whole. We're multiplying that by the 4,000. Now, I'm not going to grab my calculator, even though it's nice and handy, because I'm going to use my basic percent facts here. 10% of 4,000 equals 400. So if I divide the 4,000 by 10, I get whatever 10% is. So if 10% of 4,000 is 400, then 20% of 4,000 is double that, is 800. And that's what they said it was. So that one's true. Remember, any point you want to, you can go back, you can look over this work again. We'll stick that up there, and we will do the next one in green. The family budgeted $200 more for utilities than for other expenses. So we have utilities and we have other expenses. And it says they budgeted more for utilities. But we can see the utilities bar is actually shorter than the others. So they budgeted less. Less. That's false. I don't even have to do the math on that. I just have to read the graph. And finally, they budgeted $1,200 more for rent than food. So there's the rent, 50%. There's the food. We already solved that the food was this 800. Got to change colors here because we want our work to be in different colors. So this will be that'll be my problem D work. So we know that food equaled $800. We know that from doing part B. And we know that rent equaled, we did the rent, we said that was $2,000. If you look up at what I made small right there, was $2,000. And they're saying they budgeted $1,200 more, and that's correct, because if you take the $2,000 and you subtract the $800, you get $1,200. That is true. All right. Using our horse race idea, we are at the finish line. Here comes the last one. All right, number 42. Trent spent 50 minutes at the neighbor's house. He spent 2/5 of the time swimming. How many minutes did Trent spend swimming? So we are using our diagram that we did with our inquiry lab. We've taken the 50 minutes and divided it into 10-minute blocks. So we know each of these blocks is going to be 10 minutes in size. So I'm going to just label my blocks 10 minutes each. Now, I want to know how much time was spent for 2/5 of that. So the whole thing, if I do this entire thing, that's 5/5, which equals 1 whole. But I just want 2/5 of it. I just want that space right there. And that space right there represents 2 blocks of 10, or 20 minutes. So Trent spent 20 minutes swimming. And I wish I had started that just a little. I had written that a little different, so I'm going to scoot that down so I have just a little more room, because I want to write it out as a really good sentence, and then my pen goes crazy. Don't you hate when your pen goes crazy? Trent spent 20 minutes swimming, period. All right, so any of these that you need to look at, go back, check them out again. Remember, you're in total control of the speed of this, okay? And you've got some more practice to do, so work on that. Get really good at percents. Percents is one of those things that people don't usually have to ask, when am I ever going to use this in real life? Because in real life, we use percents all the time. Okay, great. If you have any questions, be sure to ask.